Action. Hello everyone, this is Sreyas from Maharaj Institute of Technology, Mysore, and today we are going to present our project presentation. And our project is Explainable Deep Learning Model for COVID-19 Diagnosis under the guidance of Victor Ikechukwu Agughasi, a scholar, Assistant Professor, MIT Mysore Computer Science Department. And our teammates are Sena Ahammed, Raksha K.M, and Preetham H.N. As we know, coronavirus plays a major role in these days, like affecting day-to-day uh, timetable of people, like infecting people and affecting their whole life cycle. And we know COVID-19 started on 2019 December, outbreaks in Wuhan, and it started transmitting all over the world by 2020, and many died, and many active uh, COVID-19 patients were there, and the vaccine was invented in late 2020s, and still the coronavirus is not under control. It is mainly because the testing takes lots of time, and which leads to infecting many people. And in 2021, the second wave got outbreak, and vaccine again got supplied all over the India. Many got vaccinated, and still the vaccine is spreading all over the country, all over the world, and expecting third wave, like and Omicron variants. This is the brief introduction regarding the coronavirus from past 3 years. Next, yeah, coronavirus can be tested or diagnosed or detected by two ways, that are RT-PCR and VAT. RT-PCR means reverse transferase polymerase chain reaction, and VAT means rapid antigen test. As you can see in the image, a small cotton stick which is inserted into our mouth or deep throat to collect the swabs or to collect the sample, and this sample is preserved and taken to the lab, where from the swab it is polymerase chain reaction is happened, and from there we are going to detect whether the person is infected by COVID-19 or not. And in rapid antigen test, the from the swab, the antigen is tested whether the COVID antigen is present in that swab or not. This is what actually doing currently, and many are diagnosing it through chest X-rays and CT scan also, but it is not that much developed. It is under review currently. Yeah, this is what actually the reaction of people while testing. The main drawbacks of the clinical tool currently in users are it is expensive. Yeah, though it is available for free from government people, but still it is an expensive for the government. Government spends a lot of money for testing kits and uh, for testing procedures and from labs for manpower and all. And it is less sensitive. There are many sensitivity in these testing procedures. Next. And and a clinically approved or skilled person is needed for uh, testing, and it is very time consuming since many laboratories doesn't have the polymerase chain reaction testing. So the testing happens in main laboratories, so it should be taken there and tested there, then the result is obtained. So it is very time consuming also. Hence, we come up with a solution by detecting the COVID-19 using chest X-ray and CT scan images by pre-trained model, and we are expecting the accuracy of 96.78% with sensitivity of 98.66% and specificity of 96.46%. Yeah, to explain objectives, I invite my friend Preetham.
Thank you, Shreyas. When we come down to the objectives, first, what we are gonna see is to study various approaches used to detect COVID-19. As my friend told, we are currently using RT-PCR and RAT and few X-ray scans and also serology test. Next, we have we use pre-trained models and transfer learning approaches for lung segmentation. What's a pre-trained model? Instead of building a model from scratch to solve a similar problem, you use the model trained on other problems like the models which have been previous. Instead of starting from the beginning, like example, if you see, you can take coding. Like if you want to code something new, you want to start from the beginning, run some tests and wait for the results to come. Instead of that, we have like similar kind of codes which we can use and get a result quickly. Next, what we are going to come up with our project means we are using X-ray, chest X-ray and CT scans for testing COVID-19. Like after testing, we are categorizing into four main columns, what the person is affected by. First one is COVID pneumonia, viral pneumonia, and normal using deep learning. In deep learning, we are using CNN, which is convolutional neural networks, and that's it. Next, methodology is explained by my friend Sena.
Hi everyone, this is Sena. So in our system, in our project, we are first going to select a database which can actually give us clinically approved chest X-rays, which is classified into all the three categories which my friend just spoke of. See, as you can see in this PPT, we have placed an X-ray image, one of which is a normal one, the A, and B, we have a viral pneumonia X-ray image, and C is of the same thing. Next, Preetham. To process these chest X-ray images and then find out or classify it into these three categories, we are going to use a CNN model, which is nothing but a convolutional neural network model. So in our proposed system, what we are going to do is we take each of these images, we pre-process it, and then we input these images which are pre-processed, and the image augmentation of these images are also done, and these inputs are forwarded to a deep CNN model. Actually, in here we are using 8 CNN models, and then we are classifying it either into a normal X-ray image, a viral pneumonia, or also COVID. And so here what we do is, in the pre-processing stage, we actually set the dimension of our X-ray images according to the model we are using. Each of these models may require a different set of dimensions for the X-ray image. So we actually resize them, and then we also apply some filters so that whatever we are looking for is seen much more clearly. And we take the accuracy of each of these 8 models with and without image augmentation, and then find out which model is giving us the best result, best accuracy, so that we can actually go for one of the CNN models which were listed there. Next. In pre-processing, what we have to make sure is some of the images we are going to get may not be aligned properly, may not be sized properly. Some of the portions which are of our concentration may not be seen clearly. So what we do is we first pre-process these images. That is, any zooming or removing of any areas which are not actually required for our processing. All of these are actually removed from our image, and then whatever is required is kept in there. Next. As I was saying, image augmentation is not, we actually take an X-ray image, we flip it, we rotate it right, we rotate it left, we turn it upside down, we do all these kind of things so that when our database is small and then we do the image augmentation, we have a larger number of images to do the processing, which will actually result in a better accuracy for our model. Next. And in our project, we have used both we have used our CNN models with and without image augmentation. And as we can see, the detection or the steps in which the problem is solved is different for each CNN model. For SqueezeNet, we have different models in which the X-ray images are split and then processed. In DenseNet also, we have a different method, and so in ResNet. Next. To calculate the performance, we are actually using this formula where we actually look into the true positive, true negative, and then false positive and false negative. We calculate the accuracy, precision, sensitivity, and F1 score of each of these CNN models with and without image augmentation. And then we find out which CNN model is actually giving us the best performance. And then we go for that particular CNN model. Next. The pending works we have will be explained by Raksha. Thank
you. The pending works in our project are dataset creation with clinical annotations and detailed literacy survey on existing approaches, comparison with the state of arts model, then the development of suitable classifier for the diagnosis, development of both web and mobile based CDSS application. CDSS is clinical decision support system to detect the COVID-19 from chest X-ray and CT scan images. These are the pending works for the next step, and thank you. Please do like, share, and subscribe.